Hello all, welcome back to my data structure series. Today we are going to talk about QADT. Fine. Let us imagine a movie ticket queue. Imagine that you are standing in a queue collecting your favorite movie tickets. The first person who enters the queue should get the ticket first. Is it not? That is justice. Right. Now let us assume that 50 to 100 people join the queue. New persons, that is 50 to 100 number of people, those who are joining will join at the end of the queue. If they join in the front of the queue, people in the front waiting for the tickets will not allow them. So this is exactly what a queue ADT means. This arrangement, I call this to be FIFO, first in, first out. A queue ADT defines operations where insertion happens at one end and deletion happens at the other end. So what are the QADT operations? There are 5 operations: NQ, DQ, peak, is empty, and is full. Let us understand the operations one by one. Before which, this is my initial arrangement of the queue. There is a queue and 2 elements, 10 and 20 are there in my queue. So insertion happens at the end. The end is called the rear end. And deletion happens at the end. That end I call it to be front. So imagine front and rear to be pointers. The first operation is NQ of X, which is going to insert an element X to the rear end of the queue. The next operation is called as DQ, which removes an element and returns the same element from the front. So let us see a quick visualization of the same. NQ of X. So 30, X is 30 here. I have inserted 30 at the rear end of the queue. If I am deleting an element, see, the element is removed from the front. 10 is being removed. So this is what NQ and DQ means. Number 3 is peak. So this is used to view the front element. And this returns the front element without deleting it. The 4th and the 5th functions are is empty and is full. The operation is empty is going to return true if queue has no elements. Is full is again optional, depends upon the implementation purpose. Returns true if queue cannot accept more elements. So this is an example of a restaurant ordering system. As you can see in the example, customers stand in a queue and place their orders. Orders are processed one by one. The first placed order will be served first. What could be the operations that you can see? Add order, serve order, get next order, is empty, is full are all the operations. And this serves a lot of purpose. Right? So the restaurant ordering system is an ADT that defines only what operations are allowed. How these operations are internally implemented. So I can implement queue using an array. I can implement queue using a linked list. So that is not a part of ADT. How these implementations are being done is not known and not needed here. Different implementations can be used, but the operations remain exactly the same. So you can imagine ADT to be a contract that tells you what should be done and not how it should be done. Thank you. Happy learning.